Good afternoon, learners. Welcome to today's lesson. Our focus today will be on calculus of motion, or calculus of motion, yes. My name is Khajile Mampolo. I'll be taking you through it. Now, before we get to the calculus part of this, let me just take you through the physical motion quantities. Now, first one, we can talk about the distance. The reason why I say height, distance, or displacement, both height and displacement are distances. So we know that the vertical height is the vertical distance or length, and then height must be perpendicular to the horizontal plane. Now, displacement is a distance in a specified direction. So displacement is also a distance, but it's a distance in a specified direction. The science learners, I know, don't understand this very well, because now they deal with these physical quantities more often. Now, if I say I travel with, or I travel a distance of 100 kilometers, if I don't specify the direction where I'm going, it's a distance. But if I say I'm traveling with I'm traveling 100 kilometers going to the west, then this is a displacement. But remember, in maths, we are not interested in the definitions and all these kind of things. But I just wanted to show you that when you see the word displacement now, you must know that it's like we are talking about the distance. Okay, displacement. Okay, displacement. Yes. Now, let's say the next one is the speed and velocity. The speed is the rate of change in distance or displacement, speed or velocity. So just like when you talk about distance and displacement, velocity and speed, they mean one and the same thing. And then velocity has direction like displacement is. But remember, I said there's no need to talk about the direction that much. But I'm just trying to say, if you see velocity, you must the speed must come into your mind. Now, that is why I'm saying speed or velocity is the rate of change in distance or displacement. This means that the derivative of distance or displacement is a speed or velocity. So if you are given the expression of displacement or distance or height, if you are required to determine the expression for the velocity or speed, you differentiate that expression of distance or displacement or height. Then the answer you get, it will be either speed or velocity. Acceleration is the rate of change in speed or velocity. So meaning that if you know the expression for the velocity or speed, if you are required to determine the expression for acceleration, it means you will differentiate that expression of velocity or speed to get the expression of acceleration. So for you to get, if you are given distance or displacement or height, to get velocity or speed, you differentiate the expression of distance, displacement or height. If you're given velocity or speed, and you're required to determine the acceleration, you will differentiate acceleration, because acceleration is the change in velocity or change in speed. Remember, in calculus, when you see the word change or anything to do with change, you will differentiate. Let's take a look at this simple example. Albert throws a ball from the edge of the cliff The expression below represents height in meters versus time in seconds. Is the height at t, which is time, is equals to minus 3t squared plus 10t plus 5. Now, let's look at the first one. Now, the first question says, determine the height where the ball was thrown. Now, remember, we assume that when you throw a ball, the time you are throwing the ball at time 0. So, and then we'll start recording the motion every second. So it means it's like I'm saying calculate the the initial height. So the height when the ball was thrown, then t will be 0. So if t is 0, then it means the ball was thrown at the height of 5 meters. It means this cliff is 5 meters. Second question. If I say now, determine the height of the ball in the 3rd second. So it means 3 seconds after the ball was thrown. It means now you'll just substitute the original equation. So it will be minus 27 plus 30, which is then it will be 3 plus 5. Then it will be 8 meters. This means that by me looking, you can see that the ball was thrown, or it was projected vertically upwards. If the height increases, it means it was going up. But if they say determine the height of the ball 3 seconds after it was thrown, you just substitute 3, because time is in seconds, 3 into you substitute t as 3, then the answer will be 8 meters. It means the ball was thrown in the 3rd second. The ball was at the height of 8 meters. Remember, it was thrown from the edge of the cliff. It means in number 1, we determined that the cliff is 5 meters high. The third one, calculate the speed or the velocity of the ball when it leaves Albert's hands. Now that we're talking about velocity or the speed, and then we were given the expression of the height, which is the distance, then for us to get the velocity, remember when we talk about when the ball was thrown, we know that t is 0, but we no longer talk about the height, we're talking about the velocity. And we know that velocity is change in height or change in distance or change in displacement. So remember, velocity is the same as speed. Now, you differentiate first because velocity is the change in height. So you differentiated. Remember, this was minus 3t squared plus 10t plus 5. Then it means 2 times minus 3 is minus 6t. Then here it will be 10. Then you substitute your time as 0. What does this mean? It means that the ball was thrown vertically upwards, or the ball was thrown with the initial speed of 10 meters per second. It means that when the ball left the thrower's hand, when the ball left Albert's hands, it was traveling with 10 meters per second. So that's the initial speed or the initial velocity. Remember, initial velocity means time would be 0 in that case. Now, calculate the speed or the velocity of the ball a second after it was thrown. Now, since we are still talking about the speed, we don't substitute to the original equation. You substitute to the derivative, because velocity is change in height or change in distance or change in displacement. Then instead now we don't substitute 0, we substitute 1. The answer will be 4 meters per second. It means 1 second after Albert has thrown the ball, it was traveling with 4 meters per second. Remember, initially it left Albert's hands at 10 meters per second. Then after 1 second, it was traveling with 6 meters per second. Now, number 5, determine the expression of the acceleration of the ball. Now, as I said, acceleration is the rate of change in velocity or rate of change in speed. So it means already we know that we calculated the velocity or the speed. The expression of the speed is this one. How did you get the expression of the speed? You differentiated the height or the distance. Now, since acceleration is the change in velocity, then you differentiate velocity. Then the answer here would be -6. So it comment on the acceleration. What does this acceleration mean? It simply means that the acceleration of the ball. Remember, the acceleration of the ball. What does that -6 means? It simply means that the ball slowed down or decelerated. Deceleration is a negative acceleration or acceleration in the opposite direction. It decelerated constantly with 6 meters per second squared. Why do you say 6 meters per second squared? It is because now it's the change in velocity. Remember, velocity is in meters per second. So it means velocity, acceleration will be velocity which is in meters per second per another per second. So it means now the ball was slowed down or decelerated constantly with 6 meters per second squared. Or you can say the velocity decreases by 6 meters per second every second. So the constant acceleration. One may say, why why do we say it's constant? It's constant because after we differentiate, there's no t here, meaning that the change in t will not change the acceleration, because if t is 0, there's no t here where we can substitute. But if there was t, we'll not say it's constant because it will change with time. But here, because when t is 0, it will be -6. When t is 1, it will still be -6 because we don't have t where you can substitute a t. That is why I will say there's a constant acceleration. I hope you found today's lesson very educative to you. Find it very useful, and then please don't forget to subscribe on my YouTube account. Then we'll keep on sending the videos of the lessons that will be examinable in your prelim exam and in the final exam. Thank you for watching. Always know that you are valued.